And we are on air. And it is 7 o'clock on Monday evening. And you're not seeing it. We are on air. And it is 7 o'clock on Monday evening. And okay, slight delay. So we're just you're not seeing it. We are on air. Okay, I've got to fix. Okay. Eric, can you hear me okay?
I can, yes.
Okay. And I just wanted to welcome everybody. And I'm just we're having a few technical issues tonight, but I think we're gonna work through them okay. I've got Craig watching the chat for me for a few minutes. Craig, can you see me okay? Okay, and Faith is inside our hangout, and we are here tonight with my Marlboro Graduate Center class, Marlboro College class, who have been studying or playing with vinyl and laser and CNC cutting this week, learning a little bit about each of these. And Eric Roy is going to be our guest speaker. And Eric, I've asked him to join us because of his experience with vinyl cutting. And I thought maybe he could shed some light on some tips and tricks and why vinyl cutting. Many of us think of laser cutting in terms of a great tool for Makerspace, but I find that vinyl cutting is a great way to get started. It's a great on-ramp, and I think it helps you build the confidence for going into working with a laser cutter or a CNC machine, and it's really accessible. So Eric, I'd like you to just chat a little bit about your role right now. I know I met you as a member of our Makerspace at the generator, and at that time you had an amazing studio, and maybe you can tell us a little bit about that before we start in your current role.
Happy to. Yes, thank you so much for having me. And this is definitely something that I would love to speak on. I don't even know where to begin. I've been a maker all of my life, and I happen to fall into the generator community through a natural consequence of events, and it has kind of shifted so many things in my life, but I feel like a lot of things have fallen in place. I was one of those folks that when I went to college, I had career ADD and I wanted to do everything, and I kept changing majors, and only recently have I realized that I was training myself for a job that didn't exist yet, and that all of these years facilitating and operating makerspaces is quite a bit of what I have been seeking to do with my time and my energy. Thankfully, due to the experiences that I gained at the generator local makerspace, I was able to obtain a position running the St. Michael's makerspace facility, and have been able to really steer that project towards a few of my community and service-oriented goals, as far as the areas that I see makerspaces being able to impact projects like sustainability, accessibility, and things along those lines. There's a bunch of information available out there. We have a VPR morning edition coming out, I think Tuesday or Thursday, about some of the modifications that we've been making to Power Wheels and how we're able to modify a user's experience of a school system for very low cost, should that individual be dealing with mobility issues. And I feel like makerspaces have a wonderful opportunity to be able to really impact the communities around them and be able to address a lot of individualized obstacles. That said, starting a makerspace and designing the tools that are available to the faculty and helping the faculty gain the skills necessary is a common issue that I encounter at a lot of conferences that I go to. Whenever I'm speaking with other folks, I've helped consult with the startup of many makerspaces. Even the St. Michael's project was just out of its infancy stages when I joined that team, and I've made a lot of process changes to help them really synergize both the technology as well as the way that the staff and the resources available to support that have been able to affect change. So one of the things that I'm going to kind of spin this webinar towards is how a vinyl cutter, whether it's a several $1,000 Roland or a Silhouette Cameo or a Cricut or Cricut, one of those cost-effective die cutters, there's a lot of ways that we can use that basic level of automation to be able to tackle a lot of unconventional projects. Am I screen sharing right now?
You are, and I
Okay.
just want to mention, if you're listening to Eric, we won't be having him on video today, but he will be able to share his screen and his audio. So if you're looking for Eric's video cam, it's not working, but he is able to share his screen, which I think is going to have some exciting opportunities and things for us to try.
Yeah. So the first thing that I had come across when I was looking at unconventional materials and vinyl cutters, just to make sure that the personal experiences that I had relevance to what my peers and other educational centers had been doing, I came across this wonderful Make magazine article. And what I plan to do is I will send all of these links to Lucie, so she will be able to make them available to this community, and hopefully post them in conjunction with the video, so folks will be able to follow those links afterwards. But as many of you are probably aware, Make Magazine is a wonderful starting point for a lot of projects. They have some great writers, and through this article, I came across a bunch of projects that I was surprised to find that I had thought were my original ideas, but no. Apparently, a lot of other people have been doing these things. So that said, I would definitely recommend this particular Make Magazine article as a launching point when assessing what kind of a vinyl cutter you're interested in, because as they list the projects, you may find that there are particular pieces that you're attracted to over others that might steer you in different directions. Excuse me. So I think one of the most common approaches to non-conventional uses of vinyl cutters. Actually, let me back that up. I'm assuming that many of you are familiar that a vinyl cutter is designed to cut vinyl. They typically either feed a roll of material or a specialty cutting mat through their feed mechanism. And then they have a blade that moves back and forth and knows when to lift and when to depress and cut your material out. So very similar to a laser cutter, you're able to get a high level of precision when cutting through material, but you do need to have a certain amount of understanding of the way that machine is going to work when deciding what materials you can and cannot feed through it. My number one recommendation and my caveat, because I work in a lot of shared community spaces, please bring your own blades. If you are going to be using these machines for something other than they've been intentionally designed for, you may put a lot of wear and tear, and bringing your own blade will increase the good graces of the operations manager of whatever facility you're working at. And sometimes when cutting through these materials, you can take chips and dings out of the blade, which will cause issues for whoever's using it afterwards. But I am going to go through a bunch of unconventional uses, and we're pushing the envelope of what materials really can be fed through. So normally when we're thinking about a vinyl cutter, we're thinking about standard stickers. We're thinking about a single material that's going to be fed through, and you're going to cut both a positive and negative image. And then after much time with some tweezers and other assistive devices like X-Acto blades and things like that, you'll decide what's your negative space. You'll remove all of that. And you'll use a transfer material to lift that adhesive vinyl off from its support material, which is typically a waxed paper. And then you'll apply it to whatever your final application is. This could be used for sign making. This could be used for relief work with painting. This could be used for a great number of things, just as its intended use. But this particular tool set gives us the opportunity to use computer numerically controlled code to drive and direct 2D images to be cut out of almost any material that this blade can penetrate. So one of the first questions to ask yourself is, what kinds of materials will I be cutting? When you're deciding what material, what type of machine to purchase, knowing what the blade force threshold will be is very important. There's a lot of information out there as far as how many gram force units or newtons of force you're going to need to be able to penetrate a material. And so knowing what you're looking to do in your makerspace, your fab lab, in your classroom, in wherever you're planning on hosting this equipment, if you know what your material is, that will give you a better idea of what type of equipment to purchase. I've used everything from higher end Roland machines through the Crickets as well as Silhouettes. In fact, in my makerspace, because we had so much leftover vinyl scrap, I decided to purchase a Cameo specifically so that we could upcycle more of that scrap material and get more life out of each of the rolls that we're purchasing, so that way we're throwing away less useful material and going to be able to extend that life into other projects. After getting that, seeing the capabilities of that and having the adhesive mat and the ability to feed other materials through, it really got my mind spinning on some of the applications. And the area that I've spent the most time this particular semester working, I've onboarded a particular class from our art department, and we have been applying screen printing via the vinyl cutter. So as you can see in the screen that I'm sharing right now, there's a great image of a Make Magazine Android logo being screen printed with a squeegee. And it really is just that simple. You don't necessarily need to buy a professional screen. You could easily take an embroidery hoop and a little bit of fine mesh fabric that you would find at a craft store. Stretch that, making sure that there's no ripples in the material. And then once you have everything firmly attached, apply your vinyl decal. You would want to remove any of the positive space where you plan for the ink to be transferred, and then mark off all of the edges, either using masking tape or another mild adhesive film that you'd be able to stretch around the edges, and then you can squeegee to your heart's content. My art studio at the St. Michael's campus had purchased the full photo emulsion fluids and all of the baths necessary, but they realized that introducing the students to that chemistry, as well as the cost and environmental impact that was coming from that, for a design that a student was only going to be doing 2 or 3 pulls from, it was exceptionally wasteful. And when I introduced them to a vinyl cutting solution, their minds were blown, and they have been coming up with tons of 1-off or 10-off designs that they're interested in moving forward with. And now, rather than having to really think about the cost that's associated with it, they're able to think about the creativity and the different ways that they would be able to apply screen printing to unconventional objects. And so they've moved far from t-shirts and are starting to look at the potential of 3-dimensional screens and how can we wrap this around surfaces. But ultimately, using a vinyl cutter to create limited batch pulls is a wonderful way to get around the costs associated with screen printing. There's a couple of videos that I will be linking to that show both how to set up your screens, as well as the basics of using a few of the, I believe either the Cameo or Silhouette products as a way of transferring all the way through the screen printing process. But this is an area where we've, in a higher education learning environment, been able to really open the door for the art department to be able to move forward with lower cost.
Great.
Yeah. One of the next areas, and excuse me as I try to bring something in here, I'm not sure if it's going to size appropriately for this window. I'm using 2 desktops today. Can you see a dragon skull?
Yes.
Okay, perfect. So, papercraft. I have been a fan of papercraft since I was a wee lad, and cutting cardboard templates or cardstock templates is exceptionally monotonous and does a lot of wear and tear on the body. So being able to adhere that material to a transfer sheet, and you can do this with either a large-scale professional vinyl cutter or, again, the Cameos and the Silhouettes and Crickets come with an adhesive feed sheet that you're able to send through. So you can do papercraft very, very easily. And there's an amazing program, which we will link to, that is free to download, called Pepakura. And it has revolutionized a lot of the model maker and cosplayers world because it's able to take a 3D image, so any STL or OBJ file that you can throw at the software, and it allows you to pick that apart and create flat planes that are meant to join at particular angles. And I've had several of my students play around with this in order to create unconventional three-dimensional objects, which were then offset from a two-dimensional plane, so having them project out of a canvas. But there are a lot of different applications. I'm going to scroll down here and show somebody who's working on an exceptionally large sculpted object. Ultimately, this individual is cutting out just a quick paper template and applying that over cardboard because their application is going to have so many stress forces that simple paper wouldn't work. But if any of you have worked with paper mache or fabric mache, this is an amazing program. It's absolutely free, and I recommend that everybody take the time to download it and play around with it. Even if it's not something you end up using, just the curiosity factor of taking a three-dimensional object, skinning it, and turning it into a flat plane will shape the way that you approach your 2D and 3D projects in the future. This has been a game changer for me.
Can you repeat the name of the program?
It is called Pepakura, and actually let me pull up the website here. So this is Pepakura Designer, and it's being offered through softronic.com. But ultimately, several of my cosplay students, I should back up a little. I have a background in theater design, set deck and props primarily, but I've been a costume designer, I've done lighting design, I've been a professional dramaturge, and having come from a theater background, if I knew that something like this had existed, it would have saved me so much time and energy doing traditional fabric mache craft in order to create a lot of the large scale props and decorations that I had done for set design. And it's a for what it is, very intuitive interface. Anything that involves 3D CAD design, there is a little bit of a learning curve. But one of the bright things is this will take files from most any 3D design software. If you can convert it to an STL, you're pretty much good to go.
An STL or SVG, which one?
STL, so a stereolithographic image. And then from that three-dimensional image, it then will translate a 2D image, which then converts to an SVG, or to be honest, I don't remember exactly what the different output types are, but I know that I then took those and threw them directly into my Roland's proprietary software and was able to cut them without any particular issues. There are also plugins if you're more comfortable with Illustrator. You can export to something that Illustrator would be able to read, and then use the Cut Studio plugins for that to be able to export to a Roland. For a Cameo or Silhouette, or Cricut, one of the recommendations that I would have is to, as you're designing how the faces will output, make sure that you're slicing those based off of your ultimate feed capabilities through the machine. So if you are using their proprietary adhesive backing materials, you may need to scale the slice of your pieces down. So flipping back, and excuse me.
I have a question. We have a question here.
Oh, certainly.
Is this only available for Windows, the download for Pepakura?
That is a great question. I have only used it on Windows. Looking through their website, it does not tell me if there is a Mac alternative. I do not believe that it would be compatible with a Chromebook or anything that is an online interface. Unfortunately, they have yet to stretch to that area.
Got it. And
yeah.
Tell me a little bit more. Make the connection for us between this and a vinyl cutter.
Yes. So with
exactly.
Yes, with this, that is the wrong window. So with these particular designs, on this you can see all of the intricate marks and numbers that they have, or hatch marks as far as where the connection points are. You are able to feed a flat material through and cut it to these contoured shapes, which are then designed to mesh together.
Basically feeding paper through it, or cutting paper.
Yes. So when the folks that invented this software had it in mind that you would print these out on a photocopier or other standard printing solution, and by hand you would cut out several thousand different pieces, which would then come together as this larger assemblage. And being able to feed all of those vector files into your either your vinyl cutter or your die cutter, you are able to automate all of that cutting action. I can't tell you how much carpal tunnel and arthritis you are going to prevent yourself as a result of being able to utilize this particular piece of technology. To automate the cutting, Lucie had mentioned my Space It generator. I'm a leather crafter by original trade, and had been doing a lot of work using very analog methods to hand cut masks. And after over a decade of doing so, the carpal tunnel and arthritis that I was dealing with more or less evolved me out of working in that particular industry. It was only after adding laser cutters and a few other pieces of technology that I was able to not only get back into doing what I had loved, but increase the output that I was capable of as a one-person operation well beyond what I had ever dreamed of doing, even if I had hired on a team. So I can't advocate for automation enough, especially if you're dealing with something that has a tight turnaround time. And as an educator, that's one of the things that I often deal with is not, is this project possible, but can we do it within the course of a semester? And being able to utilize these technologies to automate a lot of the menial tasks where there is no learning objective associated, that is an amazing value add as an educator. When it comes to the assembly, there's a lot that I have to teach somebody. But when it comes to cutting them out, it really is, can you follow the dotted line? And while scissor skills are important, there's only so much that they need to learn. And this is a wonderful program when used with a vinyl cutter to be able to get around those particular elements.
So question I have is, so the cuts are layered like a lasagna?
I'm not sure if I would use that analogy. Ultimately, let me see if I can actually grab another picture on my other tab here. So in this, when you see the die that has been exploded in this image here, you can see that there's a couple of tabs that are fold over sides. You can even set those with particular marks. So A1, A2, A3, and you will match A1, A2, A3. And it makes it very easy for you to know exactly which areas are meant to be glued or tabbed or slotted to the other pieces. And while the dragon head and the fist might be complicated concepts for someone to start with, it makes it very easy. One of my students had spent hours trying to cut a polyhedral die, a D20, on the laser cutter. And she kept having trouble when she was assembling it, figuring out which tabs were supposed to go to which tabs. And then she ended up throwing that design into this software and was able to get it the first time through because she was able to put those attachment lines together.
Perfect.
Yeah.
What else you got for us?
Yeah, I'm seeing the time here and realize that I've been rambling for a bit. So let's move forward to some other things. We're not going to necessarily get into it, but I will be linking an amazing video to how to use a vinyl cutter to cut tinfoil circuits for a makey-makey. They even get to the point where they talk about how to back the material and what exact gram force units you will need to penetrate through that material to cut to the short point, they cut an intricate circuit pattern using 2 layers of adhesive transfer material as the backing. And that gave them enough durability to be able to use the vinyl cutter without cutting all the way through the material. So they were able to peel out the negative space that they didn't need, and they were able to create a fairly complex circuit that occupied a pretty tight physical space. They were doing a really cool keyboard where they had laser cut some acrylic and other things as far as the faceplate. Highly recommend checking out the video. But to be able to custom cut your own circuits is amazing. I've been doing a lot of work with copper tape, and while it's good for a weekend, if you have something that you're looking to make durable for a longer period of time, moving from copper tape to an entire copper adhesive sheet is an amazing jump forward. The durability that you'll have, you can apply it to tons of different surfaces. You can even apply them to three-dimensional areas. So if you need those circuits to be able to bend, rather than having to come up with multiple PCB boards and then plug those in, you can literally just bend your entire circuit around the body that you're creating. And there is a multitude of potential applications for this. Recently, I've been working with an education student who is working on creating a demonstration for elementary students as to the difference between series and parallel wiring. And we have been, with copper tape, dealing with a lot of fudge where the material is sliding, and from week to week as we come back and move the object from space to space, unfortunately the circuits are dying and we're having to paste them back together. Had we used a vinyl cutter to be able to cut the entire piece out of one singular sheet, it would have gotten around a lot of the obstacles that we were dealing with that particular piece.
So Eric, I have a question for you. I'm not sure if you can see the screen right now, but I've just been playing around with my first attempts at cutting PCB on my...
Oh, yes.
So what you're saying is, obviously this is a circuit board, but you're saying that if I wanted to do something like this on cardboard or something fun, that I might be able to just take a piece of copper...
An adhesive back copper, yes.
And so how much would be very expensive to get? It feels like we'd be wasting a lot of copper.
Well, it ultimately depends on what you are doing and how you are approaching it. To be honest, I haven't purchased any of the adhesive copper sheets recently. I did one project back at Generator early on, and for what we were looking to do, it seemed like the most viable solution. And this was back when we did have one of the earlier vinyl cutters that was present there, and we were able to feed the material through very easily. I think we ended up backing it on a piece of cardstock when we fed it through. So it was just a waste piece of like less than 32 millimeter thickness material, stuck it straight on, and then we were able to peel back off and apply it again to a three-dimensional surface. And that was one of the real advantages, was we could bend our circuit. And while you can do that with copper tape, the adhesion on that can be problematic from time to time, especially if you're layering piece over piece over piece and attempting to extend circuits in that way. I find that the adhesive material doesn't benefit the conductivity.
Great.
Just to quickly, I guess we're more or less running out of time here, but in regards to circle back, in regards to paper crafts, never underestimate the wow factor of pop-ups, pop-up books. If you Google Lothar Meggendorfer, he was one of the early German artists that was hand cutting tons and tons of different materials. But to take his designs, within 5 minutes in the machine, you are able to recreate those exact same types of physical animation and really be able to impress somebody. I do a lot of poster board presentations with my students, and every time one of them makes some type of analog animation happen, I can't express the crowd reaction to those particular pieces. Yeah.
So I'm looking, okay, I see a couple questions here. I think they were back when we were talking about the other software.
Oh, yeah.
So one of the questions I have for you is the concept of design. Vinyl definitely comes in with making really great designs. And I think some people say, oh, that's just a sticker machine. What types of learning standards or content standards do you think vinyl would really lend itself to try to elevate it from just a sticker machine?
The immediate thing that jumps out to me is helping people wrap their head around the transition from 2D to 3D. Even with laser cutters, one of my favorite things to make is flat pack GIFs. So I give somebody a sheet of wood or other material that they're punching an object out of. And same thing with the vinyl cutter. You can create two-dimensional objects which assemble into a three-dimensional space. So both the Pepakura software as well as the ability to work with circuits that you can then apply to a three-dimensional area. There are a lot of ways where, yes, you're designing in 2D, but you're having to accommodate for a three-dimensional environment that that object is eventually going to be inhabiting. And so to get your tabs and your slots and all of the other pieces that come into that assemblage pre-visualized, you're exercising a translation of thought. So you're moving beyond the flat sheet and really thinking in the three-dimensional application. As far as other learning objectives, I mean, it really depends on the mediums that you're working with. Something that I have been waiting for Generator's technology to catch up to so that I can apply the technique is using the vinyl as a mask for applying acid to metal. And I am very, very excited to be able to create distortions and patina and antique metal in very particular ways. And there are a lot of three-dimensional objects that I plan on vinyl cutting a mask, but that mask has to be designed so that it can be applied to the contours. So ultimately, I'm going to create a 3D file that has the contours of the base of the lamp that I want to then later apply an acid paste to and etch away particular areas and create oxidization in the surface. But in order to create my file, I need to understand how that two-dimensional image is going to wrap around that three-dimensional surface so that I can create the file to cut the mask that I'm looking for. Also,
right now.
What's that?
I think you just went over my head on that one.
Yes. So taking a great example is if you had a Christmas tree ornament, like a sphere that's going to hang off of a piece. How are you going to take a two-dimensional vinyl cutter file and apply that to that three-dimensional surface so there's no distortion with the application? And especially if you're going to be applying negative space and apply chemicals to the positive space to create a reaction. So say we're acid etching, getting it so that those wrap around perfectly without any wrinkle or distortion, there's a certain accommodation that you need to make and a certain amount of that material that you're going to be cutting away. And I feel like that is an amazing learning objective for students to tackle because right now, in my experience in higher education, we are teaching 2D design and 3D design as separate course majors. And it's very rare that those two worlds seem to be overlapping. And I feel like this is a particular tool set that actually brings that in. And even with laser cutters, we tend to be dealing with rigid materials and we're cutting through thicker objects. And as such, we're not distorting those finished products over another object in any way. And so coming from a set design background, being able to take a 2D mask and apply it to a 3D surface is a huge learning curve. And it's only after a lot of failure that I've gotten to the point where I can guesstimate to where I need to be. And I feel like this is an area where I've had some amazing success factors with my students as far as introducing them to a lot of different techniques that they can use and using vinyl masks as a way of being able to get around that.
Well, I hope that you'll be able to share some of those vinyl mask projects with us maybe in the future or maybe through a gallery. And
oh, yeah.
We'll be able to do that. Leather. You said that you work, I mean, I've seen your leather work and your masks. And can a vinyl cutter cut leather?
It would have to be exceptionally thin. And actually an area that I've come across is pleather. So plasticized leather is actually vinyl. And one of the main reasons why we use vinyl cutters to cut vinyl as opposed to a laser cutter, because laser cutters are becoming more commonplace in different crafting areas and school systems, makerspaces, etc., is the chloride agent. Vinyl is toxic when cut at those temperatures using heat. It releases chlorine gas. Chlorine gas isn't good for the user or for the equipment. And so the ability to cut with a standard blade is essential. I haven't tried it but I would believe as long as you have a piece of equipment that is able to apply around 100 gram force units or more, you should be able to cut that material. If you can't, you can at least score it in a way that you would with a rotary blade or some other finishing tool, then be able to apply that. And cutting pleather by hand with knives and scissors and shears, again, you're asking for a lot of repetitive stress. And depending on the magnitude of your project, using an automated solution would be a huge boon. I have cut through a lot of thick cardstocks and things of that nature, so I would believe, at least with a Roland or another large vinyl cutter, you would have the ability to apply the force necessary to cut through that material. You very likely would dull your blade quickly. And as far as the natural leathers, depending on the tanning solution, you have a very different quality to the material. For most of my applications, I use oak tanned leather or vegetable tanned leather. And with that, you have it's a very rigid material. And as you wet and dry it, it's sculptable as you're washing the tannins out of the material, which is one of the great advantages. But that would cut through a blade very, very quickly, and you would need to get a very thin material to be able to use. I could see it being applied for jewelry application or something along those lines, but with the thicknesses that I'm accustomed to using, I believe that other than scoring, you probably wouldn't be able to penetrate unless you were able to register the object and send it through multiple times. And even then, the margin for error, I think, would be high enough where I would typically pursue something else. That said, suede and other lighter, more delicate leathers, you would very likely be able to feed through. And I have seen some very interesting applications also of using other dyes and materials as a way of then masking that. And so you could place a piece of vinyl or other material that you've cut with your vinyl cutter over that. Using an airbrush, spray can, or something along those lines, color the areas, and then go through with more rigid blades and be able to remove the space to be able to create intricate patterns and lattice work and things along those lines.
Great. I don't want to keep you longer than I asked you to stay with us. I actually, maybe you and I will have to touch base sometimes about some of these techniques. I just bought the Cricut Maker, which supposedly, because I've just unpacked it, I haven't run anything through it yet, can do some very light balsa wood and has a fabric blade and an extra precision blade, which, like many things in the maker world, the machine got released before all the peripherals are released. So,
well, we'll have to add that to the Glowforge playdate that we have coming up. Yeah.
Is it there? Is your Glowforge in?
Today was the day that they were supposed to notify me, and unfortunately, my email box is sitting empty, and checked every 30 minutes on the on the mark. But I do have faith that it is on its way. From what I've read from other folks, they have been receiving theirs, so it's just a matter of days now. But I'm very excited to put that into your hands so you get an idea of what that software workflow is like, and can make some recommendations to other educators who might be interested in pursuing that as a solution.
Thanks, Eric, for joining us. Thanks, everybody from my graduate class at Marlboro College who took some time out for our guest speaker tonight. And I'll send the links that Eric sends me to you, or put them in our grad class and in the show notes of this video so that you can watch, click on them yourself. And if there's any others that he didn't get to, I'll add those also. Thank you.
Thank you.